All right, here we go with topic number 4 for our course review. This one's all about statistics. It's going to be split into 2 shorter videos, just to let you know in advance. The first one's going to go through questions 1, 2, and 3, and then the second video will cover what's left. So this one starts out with a graphing question, which seems kind of similar to our last review topic, but we're going to do something a little bit different with this one. So we're focusing on some data that's been collected and looking at analyzing it. So the first job here is to create a scatter plot using the Desmos website again. So that's linked in your handout. I've gone ahead and done that. So I will pop to the next slide and show you what the Desmos graph looks like. And then we're going to copy a version of that into our notes. So toy sales, I chose to graph on the y-axis. Looking back here, toy sales and advertising expenditures. So I think toy sales likely depends on the advertising expenditures. My thinking is the more you spend on advertising, the higher your toy sales should be, and that seems to be the trend here, and up to the right kind of trend. So there is some scatter. It's not perfectly following the straight line, but I've included on there the linear fit for us to see. So I'm going to go back to our note and show that there's a little bit of scatter. So this is not at all a perfect sketch, but this is toy sales versus advertising. And it seems to go up to the right. We can also add to that a line of best fit. Again, it's a really rough sketch, but it is labeled to say what's on each axis. So next job, find the line of best fit. So I've drawn a rough one here, and I'm going to flip back over to the Desmos screen, and we'll find the equation for that line to 2 decimal places. Alrighty, so y equals ax plus b, or something multiplied by x plus something else. The a value is going to be 33.22, and the b value 81.61. Oops, that's 33.22 and 81.61. Okay, so there's a line of best fit included on the sketch, and to state the equation, that's done. 2 decimal places after each of those numbers. Okay, next question. Still connected to the same scenario. It says state the strength of this correlation. Justify your answer. So if we look at our graph one more time and then like try to focus on the correlation, do we think there's a strong connection between toy sales and advertising expenditures, or is it a little bit less of a strong connection? And the way to look for that, remember, is how tight the scattered points fall to the line of best fit. If they were following perfectly along the line, that would be like, of course, a super strong correlation. As one variable increases, the other one goes up in a really predictable way. And we have in our graph a little bit of scatter on either side. So you can call this strong, weak, use whatever word you choose. I think stronger for this one. Strong or weak. So there is definitely some scatter, so it's not a really strong graph. If we are having a hard time deciding, we can also take a look at the R squared value. And this is an R squared of like roughly 0.8, so 80%. That's pretty good. So I'd say it's strong, but not very strong. R squared is approximately 0.8. maybe even somewhere in the middle. So this one's not like a black and white, super clear decision to make. So not very strong. We've seen lots of R-squared values of like 0.9, 0.95, 0.99. So 0.8, like it's okay, but it's not super strong. Or medium, just to fall in between those. Okay, question D. Predict the toy sales if the advertising costs were $20,000. Explain or show two ways that we can get this answer. So remember on the graph, I plotted advertising on the x-axis and toy sales on the y-axis. And our equation was 33.22 times x plus 81.61. So we're going to use that equation and we're going to plug in advertising costs of $20,000. And I'm going to be careful here because I remember that in the table of values, it said that these numbers were given in thousands. So 1,000 in this toy sales row actually means 100,000. So here I'm being told 20,000. This to me means that the x value is going to be 20. And then we can kind of say in our heads the 1,000. So I'm going to be replacing x with 20. And everything else about the equation stays the same. And then we can do some calculating. So 33.22 multiplied by 20, that's 664.4. And we're going to add the 81.61 to that. So I'm seeing 746.01. I'm actually going to erase my dollar sign and save that for my statement at the end. So this is toy sales coming out to 746. And I'm going to remember to add the word 1,000 at the end of that. So this is a prediction. Predict the toy sales. So toy sales should be $746,000. Okay, so this is like a calculation approach. It took most of my space there. I didn't quite leave enough. But there is definitely another way we can come up with that answer. We have a graph. We've got like a really rough sketch on the first page of our note, but also the full Desmos graph. And we can use that Desmos graph and extrapolate it farther, or like drag the screen, which we can do with Desmos, to see when x is 20, how high is this graph? And we'll be looking to like read a point off of the graph when x is 20. So we could just use the graph and that would be called extrapolating because it goes beyond the points that we were given in the question. So it's like extra, it's extrapolating. All right, so there's one more question there with this question, and it says, how reliable is your prediction from part D? Explain. So this prediction of $746,000 worth of toy sales, is it a great prediction? Is it an okay prediction? That kind of comes down to the R-squared value. And since the R-squared value is 0.8-ish, and the correlation is not very strong. The prediction is somewhat accurate, but not super precise. Okay, so with an R-squared of 0.8, like 80% fit, any prediction we make is okay, but it's not fabulous, right? So maybe we're predicting an answer is here and the point at 20 years happens to be up above the line or down below the line. It could go either way. So the prediction will be all right, but not amazing. All right, so next up is question 2. So it's a totally fresh start, different scenario. And in question 2, we're looking at some of these test marks, or sorry, assignment marks. Broken down by category, so knowledge, application, thinking, inquiry, and problem solving is what TIPS stands for, and communication. And this is their set of marks. 12 out of 30 for knowledge, 15 out of 20 for application, 15 out of 25 for thinking, and 70% for communication. It would be helpful if those were all in the same like type of unit. So these ones are fractions, this one's a percent. I can do 12 divided by 30, multiply by 100, and turn this into 40%. 15 divided by 20 is 0.75. So that's actually 75%. 15 out of 25 is 3 out of 5. That's 60%. And this one's already 70%. So no work to be done there. And now they're all in the same form. Okay, next part of this scenario says that there are weighting factors that are going to be applied. The knowledge section and application section are worth 20%. Thinking and communication are both worth 15%. So these ones, I'm just curious, but these add up to not 100%. There's 20, 40, 50, 60, 70%. So it's like a term mark kind of weighting. So they add up to 70%. Just kind of interesting to know. So our job here is to find the person's overall mark, which is a weighted mean or weighted average for this particular, I should say, assignment. All right, so for the weighted mean, we can take their mark as a percent and then multiply it by the weight factor, which also happens to be a percent this time, and then add it to the next one. Their next mark, which is the 75%, and we'll multiply it by their weighting factor that corresponds with that. And then finally, after adding all those up, we divide by the total of all the weight factors, which is what I just found of 70%. So we're going to do that stuff. The knowledge mark, they scored 40%, and the weight factor is 20 or 20%. For application, they scored 75%. That's worth 20% of the mark. Their thinking section was worth 60, or they earned 60, and it's being weighted at 15%. And finally, communication scored 70%, and it's worth 15. I'm going to divide those by the total of all of the weight factors, which I already found, but I'll put it here anyway. 20 and 20 and 15 and 15. Simplifying that, I'm going to do 40 times 20, add 75 times 20, add 60 times 15, add 70 times 15. That might work fine in your calculator. You might need to package the multiplications together with brackets. But my numerator answer is 4,250 divided by 70. Okay, so 4,250 divided by 70, that is about 61%. So this person scored a weighted mean of 61%. Okay, so we're going to do one more question in this video. That's number 3. This is about percentiles. And like where a score falls within this ranking system. So the following are final marks for students in class. So there's a whole bunch of them. We should actually count up how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there are 13 scores in total. That's what N represents. And then to do the rest of this question, it would be really helpful to have the list sorted in order. So I'm going to look for the smallest numbers, 32, 44, 51, and 61, 63, 63, 67, 67, 79. Oops, there's a 68 there. And then 79, 79, 82, and 90. Okay, if it's helpful, you can put commas between the numbers to make sure you see where they separate. And then we're ready for the percentile calculation. So the formula, this is in our notes. This says percentile rank is the number of lower scores plus half times the number of equal scores times 100 divided by the number of scores. And in this one, it says that the mark, I kind of wrote on top of it, but let's see. What is the percentile rank for a student with a mark of 63? All right, so how many scores are lower than 63? Let's see, 1, 2, 3, 4. 4 scores are lower. And then the number of equal scores, is there anything equal to exactly 63? And yep, there's 2 of those. Okay, so this is ready for the formula now. Percentile rank is equal to the number of lower scores, which is 4, plus 0.5 times the number of equal scores, which is 2. We'll find that and then multiply by 100 and divide by n, which is 13. So all of this, if you carefully get it in your calculator, should give a result of 38% for a score of 63. They would be in the 38th percentile. And a final question for this video says what score is in the 75th percentile? So we're going to be looking at the ordered list. Ordered list. And try to figure out what is 3/4 of the way along. So there's halfway, 3/4. It's going to be somewhere up here, but I'm not sure if it's 68, 79, somewhere in between those. But it's going to be somewhere up in that upper end. There is a formula for finding the position. What scores in the 75th percentile? Oops. P is percentile. And position of the score is on the other side. So the position is equal to n times p. There were 13 scores in this list, and the p-value, the percentile we're talking about, is the 75th. So I'm going to change that to a decimal to use in my equation. Multiplying those together, I get 9.75. I'm going to round up to approximately 10. And now I can look and find the 10th score in the list. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the 10th score is a mark of 79%. Alrighty, so I'm going to stop the video here and do a fresh one for the last couple questions.